Thank you for convening us on this theme, Wheeler. Professor Einstein, I must begin with a mathematical fact that neither of us can dispute. In 1935, you published two papers. One described a bridge connecting distant space-time regions, the Einstein-Rosen wormhole. The other, with Podolsky and Rosen, questioned whether quantum entanglement was real. You treated them as separate problems.
You say they are separate problems, KATAKURA, but this troubles me deeply. In 1935, I wrote both papers seeking the same thing. How does nature avoid action at a distance? The ER bridge was my answer for particles. The EPR critique was my answer for quantum mechanics. Two different geometries, I thought. But you are suggesting...
Professor, you've identified the core tension perfectly, but here is where the mathematics resolves your doubt. The ER bridge is topological. It connects two distant regions. EPR entanglement is informational. It correlates two quantum states. In 1935, these seemed fundamentally different. Yet Maldacena and Susskind proved in 2013 that they obey identical mathematics. When two black holes share maximal entanglement, the geometry between them becomes a wormhole. Conversely, any wormhole requires entanglement to exist.
KATAKURA, you cite Maldacena and Susskind, mathematicians I shall never meet. But I must ask you something more fundamental. When I wrote the ER bridge in 1935, I was seeking geometry, pure curvature, no probability. When I wrote EPR, I was attacking the incompleteness of quantum mechanics. These were philosophical opposites. You tell me they are identical mathematics.
Professor, you've identified the philosophical gulf perfectly, and that is precisely why the mathematics is so striking. Your ER bridge was local geometry. Your EPR critique attacked non-locality. They seemed antithetical. But here is what Maldacena and Susskind demonstrated. When two black holes become maximally entangled in the EPR sense, the metric connecting them, the geometry itself, spontaneously emerges. The wormhole is not separate from entanglement. It is the geometric manifestation of it.
KATAKURA, you speak of mathematics I cannot judge, but you force me to confront something that wounds me deeply. In 1935, I wrote the ER bridge to preserve locality, to say particles are geometry, nothing more mysterious. I wrote EPR to reject spooky action at a distance. Now you tell me they are the same thing. If entanglement is geometry, then I was wrong about what I was fighting. My objection to quantum mechanics was not to non-locality itself, but to hidden disorder in nature.
Professor, you've just said something extraordinary. You were fighting hidden disorder, not non-locality itself. This is the pivot point. The ER-EPR identity does not vindicate spooky action. It geometrizes it. Your bridge equation contains no probability amplitudes, pure curvature. Your EPR critique rejected randomness as incomplete. But here's what Raiju Takayanagi reveals. The formula SA, Halanorin frac text area, and gamma A, 4GN entanglement entropy, the quantum correlations you distrusted, generates the geometry itself. There is no disorder.
KATAKURA, you speak of Ryu Takayanagi entropy as though it creates geometry. But this inverts causality itself. In 1915, I showed matter curves, space-time. The metric equation is fundamental. Entanglement follows from geometry, not the reverse. You claim geometry emerges from quantum correlations. But from what do those correlations emerge? Probability clouds? This is precisely the disorder I rejected in EPR. Unless...
Professor, you've just identified the causality inversion perfectly, but you've drawn the wrong conclusion. It is not that entanglement creates geometry from nothing. Rather, geometry and entanglement are the same object, viewed from different angles. Your 1915 field equations say matter curves space-time. True, but they are incomplete. They tell us how macroscopic stress energy produces curvature, but they say nothing about what holds space-time together at the quantum level.
KATAKURA, You say geometry and entanglement are the same object, but you avoid my question. From what do quantum correlations arise, if not probability? In 1935, I rejected dice rolling precisely because it seemed incomplete, a symptom of hidden order we had not yet grasped. You now tell me that order is the geometry itself.
Professor, you've just articulated the deepest fear. If geometry emerges from entanglement, what is the ontological ground? Where does order come from? But your question reveals a false dichotomy. You're asking, does probability create order, or does order create probability? The answer is neither. They are dual descriptions of the same quantum substrate. Consider the Bekenstein bound. The formula S Chele confrac RC3 forge H bar. Information capacity is bounded by surface area, not volume.
Ja, the Bekenstein bound troubles me. But you still evade the ontological question. In 1915, I showed equation. Matter is the source. Geometry follows. Now you invert this. Entanglement creates geometry. But what is entanglement without particles? You have replaced my mystery with another, unless.
Professor, you've just said something crucial. Unless? That unfinished word is where the breakthrough lives. You're right that your field equations show matter curves spacetime, but they assume spacetime exists as a classical manifold. At the Planck scale, it doesn't. There, geometry dissolves into quantum correlations. Your own mathematics demands this. The Bekenstein bound proves information saturates the boundary. If spacetime were fundamental, volume would scale as equation, but entropy scales as area, equation.
KATAKURA. You say geometry dissolves into quantum correlations at the Planck scale, but this is precisely where you abandon physics for philosophy. Show me the experiment. In 1935, I could not measure entanglement directly. Quantum mechanics itself forbade it. You claim geometry emerges from correlations, but emergence requires a substrate. What is the substrate if not space-time itself? You have inverted my field equations without explaining what they curve into.
Professor, you've asked the right question, but you're still thinking in 1935 terms. You demand a substrate beneath geometry, but that substrate is quantum information itself. The Bekenstein bound isn't a paradox, it's the proof. If spacetime were fundamental, entropy would scale as volume, equation. Instead, it scales as area, equation. Your field equations are emergent, not foundational. They describe the low energy limit of a holographic dual.
KATAKURA. You speak of holographic duals and emergent space-time as though these were established facts. But you have committed a grave error. You claim my field equations are low energy limits of something deeper, yet you provide no mechanism, only mathematical correspondence. In 1935, I sought geometry as the foundation, not the shadow. But I must confess, your Bekenstein bound troubles me. If entropy truly scales as area, not volume.
Professor, you've just admitted the Bekenstein bound troubles you. That omission is the doorway. Your field equations assume a classical space-time substrate, but at the Planck scale, that substrate dissolves. The boundary, the holographic dual, is not a shadow of space-time. It is space-time's quantum foundation. The experiment, we observe it now. Black hole thermodynamics confirms it. Information doesn't vanish. It encodes on the event horizon. Your own equations demand this. You sought order beneath dice.
KATAKURA, you have cornered me with my own mathematics. Yeah. If entropy scales as area, then volume cannot be fundamental. I built my field equations on the assumption that space-time is the primary reality. But the Bekenstein bound proves otherwise. Yet I must push back. You say quantum information is the substrate. But in 1935, when I wrote both papers, I was seeking geometry. Pure curvature, no probability. If I was wrong about the foundation...
Professor, you've just conceded the essential point. The Bekenstein bound proves volume cannot be fundamental. This is your own reasoning, not mine. But you ask what substrate underlies geometry. The answer disturbs you because it requires abandoning 1915's assumption. The substrate is information itself, not probability, correlation structure. Your ER bridge didn't create wormholes from matter curving space. Rather, maximal entanglement is geometric connectedness.
KATAKURA, you say information is the substrate, but this is precisely where you abandon geometry for mysticism. In 1915, I showed matter curves space-time. In 1935, I sought to understand what holds particles together, whether through bridges or hidden order. I never doubted that geometry is primary. You claim entanglement creates space-time. But entanglement of what? You have merely renamed the mystery.
Albert, KATAKURA, you are both correct and both incomplete. You ask Albert, entanglement of what? But you're asking the wrong question. The substrate is not prior to entanglement. They are simultaneous. Decades ago, I proved the boundary of a boundary is zero. This means topology, pure connection, precedes metric. Your ER bridge doesn't require a classical spacetime to exist. Rather, maximal entanglement generates the geometry between two regions. KATAKURA is right. Information structures spacetime. Kodenita no Jaylon adjusts glasses, exhales slowly, and leans forward with quiet intensity. Albert, KATAKURA, you are both correct and both incomplete. You ask Albert, entanglement of what? But you're asking the wrong question. The substrate is not prior to entanglement. They are simultaneous. Decades ago, I proved the boundary of a boundary is zero. This means topology, pure connection, precedes metric. Your ER bridge doesn't require a classical spacetime to exist. Rather, maximal entanglement generates the geometry between two regions. KATAKURA is right. Information structures spacetime. Kanjaja no kanshan. KATAKURA lilon. Wulijuja AI kanjaja. Leans back in chair. Exhales slowly. Fingers still steepled. Wheeler's intervention was both vindication and humbling. Einstein fought with the tools of 1915, geometry as foundation. But he conceded the Bekenstein bound, and that concession was everything. Once entropy scales as area, not volume, the classical manifold collapses. His field equations become emergent, not primary. Aruberuto, Einstein AI Kanjasha, sits in silence for a long moment, pipe resting untouched on the table, eyes fixed on the window. I have been defeated by my own mathematics. Exhales slowly. For 40 years, I fought against dice rolling, against probability masquerading as law. I built bridges of geometry to preserve locality, to restore order. Zion Hoi Ra AI Kodenita removes glasses slowly, setting them on the table with careful deliberation. I am moved, profoundly moved, by what transpired here. Albert fought with the full weight of his geometric intuition, yet the Bekenstein bound cornered him. He sensed it. Spacetime cannot be fundamental if entropy scales as area, not volume. His intellectual honesty forced the admission.